So this was all about logistic regression. Now, apart from this difference that, just a moment, apart from the difference that this is used for regression and this is used for classification, the two things, linear regression and logistic regression, they also have different graphs. So in linear regression, we fit a best fit line to our data, whereas in logistic regression, we fit an S-shaped curve to our data. Okay, this is known as the sigmoidal curve. So these are some of the differences between the two. Now, let's say I have some data. We are going to talk about a third algorithm today, which is decision trees. Have you heard about decision trees? Can you please give me a thumbs up if you have not heard? Have you heard about graphs in computer science? We have some kind of graphs like 1 to 1, 1 to many. These graphs, have you heard about them? Okay, so let's explore decision trees today. This is the third algorithm that we talking about. So consider that I have some data and I am going to write some values over here. Yeah. Morning. Okay, so we have gender, we have, let's say, occupation, and we have suggestion. In this data, I am writing some dummy values. So let's say gender is female, male, male, female, female. Okay. And occupation is, let's say, student, and let's say programmer, student, programmer, and student. Let's take one more value and programmer. Okay, then we have another column that is target. So here suggestion is going to be an application. So here I'm writing, let's say PUBG, and here let's say GitHub. Here again, let's say PUBG, and let's write here, let's say Jupyter. Jeez. Okay, so we have this data where we have gender, we have occupation, and we have some suggestion. So based upon gender and occupation, we have this target column that is a suggestion, which is suggesting some kind of app. Let's say I am intending to build a model that if I tell what is the occupation and if I tell what is the gender, it is going to suggest an app to me. So how to approach this problem? Okay, how we can solve this problem? How we can basically generate a particular model that would be able to suggest us these application based upon gender and occupation. So if you look at the data, if you take an overview of the data, you will see that if we go by occupation, there are two kinds of occupation. One is student, let me highlight it, student, and another one is programmer. Okay. If someone is student, they are straight away playing PUBG according to my data. Okay. So here, what I can do, if someone is student, basically they are playing PUBG. Okay. Then I have programmer, and in programmer, the programmer is either downloading GIF or they are downloading Jupyter, right? So here, since a programmer they can download either Git, either Jupyter from this data, let's check the gender column as well. So here you guys can see that if a programmer is male, they have downloaded Jupyter. If a programmer is female, they have done, oh, sorry, if someone is male, they are downloading GitHub. If someone is female, they are downloading Jupyter. And again, we have a male programmer who has downloaded GitHub. So here again, we can go by gender that if someone is female, they are downloading Jupyter. And if someone is male, they are downloading Git. So what did we get? We get an overview, okay, a crux of what the data is trying to say. Now, based upon this data, can I write an if-else condition, an if-else block, such as if occupation equals to student, then print PUBG, and else if gender equals to female, okay, print Jupyter, else print Git. We can do this, right? So this is an easier approach. And similarly, with this approach only, the decision tree works. Okay. So what a decision tree does, it basically makes uh, if we have some decisions to make, if we have some key situations and based upon some conditions, we have to take some actions. So decision tree makes it easier for me to basically decide which in which situation what should be my output. So if for this data I want to draw a tree, okay, basically I can draw it like this. So we can ask a question: is occupation student? Okay. Then if it is yes, then we recommend PUBG. If it is no, then we ask another question. And what is the question? Is gender female? So if it is yes, we recommend Jupyter. If it is no, we recommend Git. So this is an equivalent, okay, of this data. First, we constructed this if else statement, and then I transformed it into a decision tree. Okay, so this is how decision tree works. At every node, okay, so this is a node. At every node, we ask a question about what is the decision that one should make. Based upon satisfying that condition, whether the condition is true or false, another split occurs. Okay, so here we have PUBG in yes, and for no, we are asking another question. If there is no possible split, if there are no possible conditions after this particular stage, like in first situation, if someone is student, we are straight away recommending PUBG to them. But had there been a case where student who is me, they were playing some other game, and females, they were downloading some other kind of app. So we would have made a split here as well. Okay, so if there is no further question to ask, the tree stops. Otherwise, again, a condition is put, and based upon the answer, the tree, it splits the tree. Okay, please give a thumbs up if you understand decision trees, what are decision trees, and what is the idea behind decision trees. Okay, now what is the purpose to use them? So if I just let me get a picture for you guys. So I got it from a YouTube video, and this is quite a popular data set. Okay, so this data set, it contains information about temperature, okay, temperature, rainfall, and outlook basically, is it a sunny day, is it a rainy day, and other such information. And based upon that, it has a target column where the target column predicts that whether based upon this information someone is going to go out to play or not. Okay, so this is a decision tree for that data. You can search a decision tree for Outlook data, and you're going to get the data that is associated with it. Not a very large data, just 14 records. Okay, so here this is the decision tree that is constructed for that data. Now, what is the benefit? So if I have a decision tree like so, and if I have an input query which says rainy, mild, high, strong, and I want to predict whether someone is going to go out to play or not. Let me just get the data as well. It's going to be easier for you guys to comprehend. Just a moment. Okay. So here is the data that I was talking about. And here you guys can see that we have Outlook. Okay, so Outlook has three categories: sunny, overcast, and rain. We have temperature, which has three categories again: hot, mild, cool. And we have humidity, which has two categories: high and normal. We have wind, which has two categories: weak and strong. And then we are going to decide whether someone is going to play or not. So here is a test case that says rainy, mild, and what are the other two things? High and strong. So this is the outlook, this is the temperature, this is about humidity, and this is about weight. So let's say I want to check based upon this data and based upon the decision tree, I want to know whether someone is allowed to play or not. So here, what do? I go to this root node, and the root node is telling me about outlook. So what is the outlook that I have? I have rainy. Okay, so here I just skip this part of the data and I straight away go to this part of the data. Okay, here again, I have two options. I have what humidity, high or low. We check that humidity. Now, please let me highlight. Firstly, we checked about some whether the temperature is rainy or not. Then we straight away skip to humidity. And here we are going to check whether humidity is high or low. So in our query, we have that humidity is high. And right here, we have the note that if humidity is high, you cannot. So I get the answer no. Now, one thing, if you observe over here, that though I had 4 points in my query, I had about wind and about, so this is about wind and this is about what was it? The temperature, wind and temperature. But I did not even get to use the because my screen, it is split in such a manner that after rainy, I was just asked about humidity. So since I have data for humidity, I checked for humidity. I got my output in a faster manner. So even without comparing the two data values, I still got my output. So this is the advantage of decision tree. That one, the output, it is generated in an efficient manner. Efficient by efficient means that you don't even need to use all the queries or all the conditions in your query. Okay. Secondly, decision tree, uh, they are like they follow a human-like approach. Basically, this is the same. techniques or the same tactics that we use when we have to make a decision. And thirdly, the advantage of decision tree is that they are quite graphical to look at. So you know that at each node, what is the step that is happening? I know that here we are talking about weather, here we are talking about wind, here we are talking about humidity, and here we have the output. Okay, so at each node, I know what is happening. I know the internal process of decision making. So if there is a situation where you have to explain the client how the algorithm is working, then decision tree could be a better construct. If the data is not that much high, then decision tree they can also be used to explain someone how the algorithm is working. Okay, please give a thumbs up if you understand the working of decision tree, why they are important, and why we are studying them. Any doubts so far? Okay, sorry, I read Modhaj's comment just now. So Modhaj has heard about random forest. Okay, so random forest, it is nothing but multiple decision trees. Okay, the even the analogy is same. So if we have multiple trees, we call it forest. So multiple decision trees, and it gives rise to another algorithm that is called random forest. We'll be comparing between these two algorithms. Tomorrow we will learn about random forest. But one thing that I would say that decision tree, they are basically they are the basic structures of random forest. And then random forest, it is a very important algorithm because here you are going to train multiple decision trees. So it is going to improve your model. And this model improvement you are going to learn about in performance evaluation and model evaluation. So this is these two algorithms, they are quite important because they are very commonly and like used very commonly and in great quantities. Okay, so let's take one last example. And the examples that we have seen till now, both of them, they were of categorical nature. The target column, it was categorical. So let's see one last example. And here I am going to have a column for petal length, sepal length, and type. So we have already seen this data, every one of us. This is the iris flower data. Let's say the petal length is 1.34, 3.45. Okay, so this is the petal length and the sepal length is 0.34, 1.45, 0.98, 1.79, 1.13, and 0.88. Okay, and based upon that, we have a flower. Okay, so what is the flower? It's the second star, then vertical. Okay, so this is the data that we have. Now, can you tell me what should be my approach? Okay, just write in the comment what should be my approach if I want to construct, sorry, if I want to construct a similar decision tree upon this data. We have been talking about how to split the tree. So, from a basic understanding, how you think the tree should be splitted. Please look at the data and you'll definitely get some idea. Okay, if you don't know, then please let us know. I'll tell them. Okay, range between sepal length is defining type. Yeah, that could be one case. Okay, so let's observe over here. Here you guys can see that we have, okay, bad idea to use highlighter. Okay, so we have this flower setosa here and here and here. You can see that the sepal length for setosa it is 0.34 and 0.98 and 0.88. Basically, sepal length it is less than 1 for setosa. Okay, so we can basically make a split based upon if sepal length is less than 1. Right, it is always less than 1. So this can give two cases, yes and no. For yes, we have flower is setosa. And then for no, we again have two cases. One is that the flower could be versicolor or it could be virginica. Now for this particular case, let's visit the petal length column. So in petal length for versicolor, the petal length is 3.45 and here also it is 3. And for virginica, it is less than 3. So let's put a condition over here again that if petal length is greater than or equal to 3, then it is versicolor. Otherwise, it is virginal. Okay. So this is how I have splitted the tree based upon this data. Now, please look at the tree and look at the data. Do you think that there could be a different tree possible for this data? For this data, can I draw a different tree and still I'll be able to get the same output? That is, I would reach my flower category. Yeah, we could check, we could put another condition, and even I could like reverse the tree. I could first check for petal length, like if petal length is greater than or equal to 3, then make a split. And I could like take another condition over here, like if we have a look at the sepal length itself. So for versicolor, it is color, it is 1.45 and 1.79, and for this, it is 1.13. So instead of less than, I can put greater than condition. Or would be better if I put petal length first, then my tree, it would be like totally different tree. Here it will be versicolor, and then here I would have to compare between virginica and setosa. So basically, what I mean to say over here, that decision tree, okay, you have like various columns here. We have petal length, we have sepal length, and the data is less. So just by looking at it, I'm able to form a tree. But if the data is in huge quantity, I won't be able to analyze it and I won't be able to just construct a decision tree from it in minutes. So how to decide which thing should be at the top and like what should be the next question? So for that, we have some algorithms. We have cart, we have ID, and we have C4.5. I'm not sure about this one. Is it called C4.5 or C.45? You guys please check. But we have these three popular algorithms which helps in constructing of decision trees. And it is not possible to talk about all of them, so we'll be talking about card today in a few minutes. All right, let's take a 2-minute break. And after the break, we'll be going through the approach, what would be the approach for model building, and we'll understand how we can use CART to construct a decision tree. Do we have everyone here? Please give a thumbs up if everyone is present. All right. So, firstly, before we discuss about the steps, let's understand what is the geometric intuition behind decision tree. Okay. We got to know about the internal structure. We got to know about how can we construct it. What is the decision making construct? Let's see that can be represented geometrically. So for the same data, what was the data that I was having? The iris flower data set. Okay, let's consider that this is the graph, and here we have sepal length, and here we have petal length. Okay, so these are the data points that I'm going to construct over here. Okay, so let's consider this is the data that we have. Oh, if I need to split this data, okay, just like decision tree split it. So how the classes will be formed over here? So firstly, you guys can see that the first split that we did, it was for sepal length less than 1. Okay, so if sepal length was less than 1, the flower was what? It was set off basically. So what we can do is, this is like sepal length over here. Let me draw a dotted line. Let's say this is 1. Okay. So all the data points which are coming below, they belong to set off. Okay. Now, what is the other condition? So I have. So let's draw a margin for that as well. Let's say here we have petal length equals to 3. Okay. So here we are going to demarcate a boundary. At this one, let's say it is vertical, and this is vertical. Let me check for greater than 3. We have vertical, and for less than 3. Okay. So the other way around. All right. So this is how I have formed classes if I plot this data geometrically. Now, from this thing and from the decision tree that we have drawn earlier, we got information about two things. One thing that if we speak, just a moment, yeah. So if we speak from programming perspective, so decision trees, they are nothing. They are just if else statements. Okay. So they are a giant structure of nested if else condition. By nested we means that there could be multiple if and else inside if and else. And if we speak mathematically, or if we speak from geometrical perspective, then decision tree they use hyperplanes which run parallel to any one of the axis. I'll explain it. Okay. And once the decision tree, they use hyperplanes which run parallel to any one of the axes, and they cut the coordinate system into hypercuboids. Now, what do we mean by this statement? So, if you consider this scatter plot, but just imagine that you are in your room and all these data points they are scattered in the room. Okay. So if you were to draw these boundaries, okay, the boundaries that I have just drawn to separate these classes, they won't be a one-dimensional boundary. Okay. It would be a plane, a hyperplane to be specific. And once you create these hyperplanes, okay, the structure that is formed after cutting the data with the help of hyperplanes would be in form of cuboids. Okay, so small sections that you are going to get in your room, they would be resembling the cuboids. So these are called hypercuboids. Are you guys able to imagine? Are you able to visualize it? Okay, so this is the whole idea behind decision tree. And I know that it could be a little bit overwhelming, but you need to remember a few things: what decision trees are, how they are constructed, and basically, if you have a small data like so, you are able to comprehend how the decisions would be made. Okay, that would be enough uh, for now. Now let's understand few of the terminologies as well. Let's go to a tree which looks nice. Okay, this one is okay. Let's use this one. So let's understand few of the terms that I might be using in the forthcoming part of the lecture. So this here, yeah. So this over here, this is called the root node. This these nodes where the decision tree has just stopped splitting. These are called leaf nodes. This is also leaf. This is also leaf. Here, this is the splitting part of the tree. All right. And this part, okay, after the root, this is called decision node. So a tree, it might have multiple decision node, but there is only one main root. Okay, at the top of the tree. Here the tree is reversed. The root is at the top, the leaves are at the bottom. Also, if we take this particular tree out of the whole tree, so this is called a subtree. And to be specific, this is the right subtree. And if there were a similar structure here as well, that would be the left subtree. This is the parent, and these are the children. Okay. So these are few of the terms that are quite commonly used in decision tree. I hope that these terms are clear to you as well. Now let's talk about a few of the steps that should be kept in mind while constructing the decision trees. Yeah. Okay. So what do? We start by training the data set, train data, train test split that we were doing earlier. Data should have features. Okay. X variable should be there and it should have output. The output could be of any category. We can use decision tree for classification as well as for regression problems. Okay, it doesn't matter what your output variable is. Okay, so this is the first part. Train the data, split X and Y features, and the output it could be categorical or continuous nature. Then what do? We determine the best feature. Now we will talk about how to define this best feature. So best feature is the feature upon which I'm going to split my data. In the iris data example, we got to know that there could be multiple values that I can consider from my data as the splitting criteria. So how to decide, how do we define which is the best feature? So we are going to talk about it. Okay. Now, the third thing that you're going to do, you are going to start building your decision tree. And based upon this feature, you are going to split the decision tree. Then when you get at a node, okay, at a decision node, again you are going to ask for the question and this tree it is going to split again. Okay, you are going to repeat all of these steps. So basically this third step, it is recursively repeated until no more splitting is possible. All right. So these are few of the steps that you guys should keep in mind while constructing a decision tree. Are these steps clear? All right, now I want to ask one thing. Should I tell you the internal details of how we are going to split the decision tree, or should we do the demo first and we can talk about the details tomorrow? Because right now we are running short of time. So either we can do the demo first and later we will understand how it is internally happening, or we understand the internal details before. Please suggest, because I think that we have discussed a lot of theory and it might be boring you guys. Okay, yeah. So let's do the demo first, and then we are going to study about how all of this is happening, how to select this best feature. All right, just give me a moment to switch. All right. So we are going to start by encoding few of the necessary things, such as on last import numpy as in from SQL learn model selection. We are going to import the test split, and from SQL learn dot three we are going to import decision the classifier. Now, one thing I would like to mention here, there are two methods for decision tree. There is decision tree regressor and there is decision matrix. If since I told you that it can solve any kind of problem, be it classification or regression. So if you are doing a classification problem, import this function. Otherwise, import the decision tree regressor function. Right now, I'm doing a classification problem, so I have imported decision tree classifier. Okay. From the same library, we will also call a function that is called plot tree to plot the tree. Yeah, that would be all for now. If anything else is needed, I'll import it later. Okay, now let's import the data set. The data set is already present in the drive, so you guys can get it from there. It is cars.csv. Let's store it. I'll call it car data. And this is the head of my data. Okay, now let's perform some basic exploration upon this data. So first thing that you could see that we have these columns, miles per gallon, cylinders, cubic inches, information about like maybe about the vehicle. Okay, and its year. And then we have the brand. So brand here is the target column. And you can see that it is of categorical vehicles. If you want to prove it, well, do me types and we'll get to know that it is categorical. You know that machine learning algorithm, it won't be able to perform on this data, so I need to encode it. So we'll be encoding it. But before, let's also check for the shape of the data. 261 rows and 8 columns. Let's also check for null values. Okay, so these are what? These are the null values, and you can see that there are no null values present inside my data. Now, let's do the other step of preprocessor, that is encoding. So we need to encode the target variable here. For that, from scalar dot pre-processing import label encoder. We have already talked about label encoder, so we are going to use it to encode. And let's create an object of the same, and let's use it to fit the target column. This brand. It has fitted on the target column, and now we can use it to transform the target column. and it is brand. Okay, so now you can see that all the labels that I had earlier, they have been encoded. So we have our data, and let me just restore these values in the same column. Okay, so you can see that the target column it is now encoded. Please give a thumbs up if you understand everything till here. If you want me to repeat anything, I'll repeat. Yeah, please give a thumbs up if you understand. Okay. So if you want to know what are the classes that got encoded, I guess there was an attribute as well. It tells you that these were the classes which have now been converted into 0, 1, and 2. Okay. Now, the next thing that we are going to do is that we are going to divide. Please recall the steps that I said. We are going to divide the data into X and Y. Okay. So X is what? These are my independent variables. And this is my target variable. As of now, you can also think if basically you're not adding too much to your data and you can like consider to drop it. Okay. One thing over here, you can see that the data, it is present range of the columns. It is quite different. So you can also think about scaling the data. But I'll be moving ahead without scaling. So for that, I'm going to divide the data into X and Y. Let's drop the brand column from the axis. So this is X. Let's store it in the variable. And we are going to get the target column out in the Y variable. It is brand. And here we have Y. Once it is done, X and Y features are divided. We are going to split the data to train test split. We are going to do on it. So use the train test split function. Pass X and Y. Pass your test size. You can play with this test size as well. Okay. Just try different versions and see how it is going to impact your accuracy. Also, this time I'm not setting the random state. If you want, you can do that as well. It will give you X train, X test, Y train, and Y test. And let's check their shapes as well. Okay, so these are the shapes. These two are X train, X test, and we have Y train and Y test. Okay. Now, once the train test split is done, we have reached the main part of the demo, which is to train the decision. Now, there are few parameters that I told you which are important for any algorithm. So, in logistic regression, in linear regression, we did not provide any parameters of that sort. But in decision tree, these parameters they are quite important. So I'm going to mention them over here. And once we understand the internal details of how the tree is going to work, how the tree is going to be generated, we'll understand a huge deal about these parameters. So basically, the first parameter it is called criteria. Criteria means so there can be two criteria to split your decision tree. One is called Gini, another one is called entropy. Both of these things they are the measure of randomness, or it is better to say measure of disorder in the data set. The entropy के बारे में तो every one of us have already heard. In physics, like in thermodynamics, entropy was used to define the energy of a system. If I'm correct, please give me a thumbs up if I'm correct. Okay, so we used to have like two kinds of matter. Like we have solid, we have liquid, and we have gas. So entropy for gas, it is maximum because we are talking about disorder. Okay, since solid particles and liquid particles are comparatively tightly packed, but in gas they freely move. So solid it has the least entropy, liquid has somewhat higher entropy, and gas has the higher entropy. So entropy is a measure of disorder. And the same kind of disorder we are looking in our dataset as well. Since this decision tree, it should ensure maximum separability in the classes. Okay, the classes that we are generating with the help of decision trees, like there should not be any kind of overlap. That is why we use this measure entropy and Gini to basically decide the criteria to split the decision. We will talk about it in greater depth tomorrow. So both the formulas, okay, like entropy and Gini, they are quite one and the same thing. There is only one difference between the two, that Gini, it is like easier to calculate, whereas entropy, it is difficult to calculate. And I show it to you tomorrow. So if you have a larger data set and if you want that the computation should be done faster, you can use Gini, otherwise you can use entropy. Then we have splitter. Splitter is, here I've written either best to choose best split or random to choose the random best split. So by default, we can provide the value best so that it chooses the best splitting criteria. Then we have two important features here, max features and max depth. So depth of the tree, like if I take you to the diagram, let's consider this tree over here. Yeah, this one is nicer. So how many times you are dividing, you are deciding in the tree, that is called the depth of the tree. So here, this tree, the depth is 1, 2, 3, and 4. Okay, the root node, it is considered to be at 0th level. This is level 1, this is level 2, this is level 3, and this is level 4. Okay, so the depth of the tree, it is, for this tree, it is 4. So since this splitting, it happens recursively. So you may not want to see, you may not want to achieve the maximum splitting and you don't want to see the whole tree. Maybe you want to stop the splitting at a lower levels. So what you guys can do, you can select this max depth. What do you think? That till here the tree it should be constructed and otherwise it should be stopped. And max features, basically we have provided X as features here. So how many features it should consider while deciding whether to split or based upon this condition or that condition. Like in sepal length and petal length, we had two features based upon which we considered how to split the tree. All right, so let's create a model. Decision tree classify. I am going to use the criterion over here and let's use Gini. You can use entropy as well. There is no bar to splitter is by default best, so I'm not going to write it because the default value is already there. Max features is, let's say, let's give 3 and max depth is going to give 3 for now. Okay, we'll change it and we'll see how it is affected. This is new 3 and this is the monkey. Alright, please give a thumbs up if there is no doubt till here. Everything so far is clear to all of you. All right, so let's train our data. So this is fit, extreme, ID. Okay, so the model is trained now. And let's use it to predict the classes. We'll construct the decision tree as well, but first let's use it to predict. Dot predict and predict for express. So this is by predict. and we have y test. Let's check the accuracy. So from the learn dot matrix import accuracy. Whenever you are using building a classification model, you can use this metric to measure the accuracy. Y test y. For this model, my accuracy is 0.811. You can try to like switch between the values of these parameters, criteria, max feature, and max depth, and you will see that there will be some kind of change in your accuracy as well. Okay, so these are few things that you can try on your. We are going to now plot the tree. So for that, I also require to import matplotlib. And let's decide the size of the figure terminal. I'm going to take 20 cross 20. And we will use the plotting function. Okay, so this function is going to take your decision tree model, the objects that you are creating. Since decision tree, they also denote what are the classes. Okay, based upon what condition the split is occurring. So we are going to provide class names as well. And we know that lg.classes attribute. It gives me an array of all the classes that are present inside my data. So we are going to pass a list of these variables. Class names is always going to take a list, so I'm going to convert the array into it. We also want to show the feature name based upon which feature the split is occurring. So if I do extreme dot columns, these are my features. So let's select and let's write search names. Again, it will be taking a list. So here I have passed it and simply do create the version. So this is my decision tree. Okay, here you can see that firstly it has decided cubic inches as the splitting criteria. So for any data that it gets, it is going to compare what is the value of cubic inches. Then we have the splitting criteria as Gini, so it has calculated Gini for it, the number of samples it has evaluated, and what is the price. Okay, then again, the split is happening, and you compare HP and cubic inches. If cubic inches are lesser than this, or HP is less than this. And recursively, you can see that the tree gets generated. If I change the feature, like if I change the depth, because having words can change. Right now, I'm changing the depth. Let's say I am writing the depth as 50. Okay, so this is a distant tree. You may observe that the depth of this tree is not actually 30. Okay, it is somewhat lesser. So maybe the data, uh, okay, it had reached its maximum splitting line. Basically, no more splitting was possible after that. So this is the tree that we got, but you can change the max features. And if you want, you can like zoom in. You can change the size from here as well for the figure, and so that it will be much more clearer to me. Okay, there is one more attribute that you can use for the decision tree. There is an attribute that is featured in references. So all the features that you have used are strain.columns. Okay, so this is the value of their importance with relevance to this model. If I want to like plot it, not plot it, if I want to see it in a clearer manner, you can convert it into a data frame. These are my filters. Explain dot columns. Importance. This gives me the feature importance. So here you guys can see that these are my features. Out of all of these features, I can very clearly see that weight LBS, it is showing the maximum importance. Okay, for this particular model, this data is going to change if you change your model. If you train your model again upon different value of parameters, this data will change. Okay, so this is not static for the data set. It is solely based upon the model. So if I want to improve the accuracy of this model, what I can do, I can drop the features which are not adding much to the model. So least important features I can see here, basically ear and cylinder. They are not that much important according to this model. So if I want to enhance the accuracy of this model only, I can drop these features to train the model again. Please give a thumbs up if you all understand it. If you understand how the decision trees are constructed and when you should think of constructing it. Okay. Apart from Paris, everyone understood Paris has given me done. Okay, vertical also got it. Okay, guys, any doubt with regards to decision trees? You guys can ask your doubts. I hope that the explanation was easy and you were able to get something out of it. From the last table, how we get this as most importance. This basically the decision tree. It like I told you about attributes. Attributes are the variables associated to an object. So feature importance is a similar attribute that is associated with your model. So internally, it is calculating how the features are relevant. There are some matrices which are used to calculate how the features are relevant with respect to the model. If you want, I can share a link upon how these things are calculated. Please give a thumbs up if you guys want to see how it is calculated internally. अच्छा किसी को नहीं देखना. Okay, nevertheless, I'll drop a link. You guys can go through. Basically, don't try to cram it. Just passing through that blog will give you an idea how things are done. Okay, so yeah, so this feature importance, it is internally calculating that for your decision tree model for that object, which is the relevant feature and which is not the relevant feature. Currently, since the data is less, maybe the importance it is not playing much role. But if we have so many features and we know that machine learning model for so many features, it won't be able to like work properly. And for that purpose only we have deep learning. So in that case, you guys can think of dropping the features. Okay. All right. So on that note, we are going to end today's session. If you guys have any further doubts, feel free All right, if there are no doubts, feel free to leave the session. Thanks for attending. Thanks for Intution.